Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have square root of c plus c is equals to 2. We solve this problem for all the values of c. So here first we find all the roots of this equation, and at the last we will be verify that which of the roots are solution and which of the roots are extraneous root. And now we move towards the solution of this problem. I hope so you like this method, but if you have any other method in your mind, so please don't hesitate to write this method into the comment section. So we move toward the solution of this problem, and the very first thing we are going to do is first we need to remove this square root sign, and for this we move the term plus c to the right hand side, and we get square root of c is equals to 2 minus c. And now in order to remove the square root sign, we will apply squaring on both of the sides, and this will be written as in this form. And further here we use the nice algebraic formula into the right hand side, and you know about that. If we have x minus y whole square is equals to x square minus 2 times of xy plus y square. You see that this term is our x and this term is our y. So now we just expand this nice formula, and we write the above equation as these 2 and this square root are gone, and we get here c is equals to, and when we apply this formula to the right hand side, it will becomes 2 square minus 2 times of 2 into c plus c square. So further we have this is c is equals to, here we have 2 square and 2 square equals to 4, and minus 2 times 2 becomes here 4c plus c square. So now in the next step we need more simplifications here to solve this problem for the values of c. So we move the term plus c to the right hand side, and we rearrange all these terms, and we get c square minus 4c plus 4, and this plus c becomes minus c, and this whole equation is equals to 0. Here we add or subtract the like terms, and we have c square minus 4c minus c becomes here minus 5c, and plus 4 is equals to 0. So here you see that after this little bit simplification, we convert our given radical equation into the quadratic form. So here in the next steps we need to find the roots of this equation. Also, you know that there are three methods to solve the quadratic equation. The first method is factorization method, the second method is completing square method, and third one is by applying the quadratic formula. So now here we use the factorization technique to solve this problem, and for this we just break its middle term, and we write it as c square. We write minus 5c as minus c minus 4c, and this is plus 4 is equals to 0. And now you see that from first two terms we have c be the common value, so that we take common c from here, and we get the remaining values are, from here we get c minus, from here we get 1, and from these two terms we again take common minus 4, and we get the remaining values are, from here we get c minus, from here we get 1, and this whole equation is equals to 0. And now in the next step, here we take common c minus 1, and when we take common c minus 1, we get the remaining values are, from here we get c minus, from here we get 4, and this whole equation is equals to 0. And now in the next step we divide this equation into the two cases. The first case is we write c minus 1 equals to 0, and the second case is we write c minus 4 equals to 0. So from here we move minus 1 to the right hand side, and we get the value of c is equals to plus 1, and from here we move minus 4 to the right hand side, and we get the value of c is equals to plus 4. So here in this method we get these are the two roots of the given equation, and now in the next step we need to verify that is these roots be the solution or is these roots be the extraneous root. So for verification of these, we need to copy down given question statement. Here it is square root of c plus c is equals to 2. And here we substitute c is equals to 1, and in this side we substitute c is equals to 4. So when we substitute c is equals to 1 into the left hand side, and this will be written as square root of 1 plus 1 is equals to 2. And now further in the next step, we have square root of 1 becomes here 1 plus 1 is equals to 2, and 1 plus 1 becomes 2 equals to 2. So this shows that both of the sides are equal. It means that the value c is equals to 1 is satisfied our given question statement. And now here in the same pattern we verify the second value of c. So when we put c is equals to 4 into the left hand side, this will becomes square root of 4 plus 4 is equals to 2. And we know that square root of 4 becomes 2 plus 4 is equals to 2. And further we have 2 plus 4 becomes 6 is equals to 2. So you see that both of the sides are not equal. It means that the value c is equals to 4 is not satisfied our given question statement. Here we finally concludes about that the value c is equals to 4 be the extraneous root of the given equation. Okay, so we write it as it is the extraneous root. And here finally we have just only one root, only one solution of the given equation, and that is c is equals to 1. So this is our final answer, and thank you so much for watching this video.